Okay, today we are going to learn a simple way to conduct quasi-experiment using two-ways Annova in SPSS. First, we need a data in order for us to analyze. The example that I'm using here is investment interest in period of crisis and non-crisis. All the data are fictitious. There are a total of 30 respondents, and I divided them into 4 groups based on these two-ways Annova model, and I code the period 1 as crisis, 2 as non-crisis, whereas the type of investment 1 equals to equity, 0 equals to fixed income. Since we have acquired all the data, let us proceed to the SPSS software. I successfully imported the Excel file to the SPSS. In order for us to conduct the two-ways Annova in SPSS, first we select Analyze, then select the General Linear Model, then select Univariate. Then we are exposed to a window of us showing dependent variable and also fixed factors. Since we know the dependent variable is the investment interest, so we select investment interest, click the arrow, and since also we know the fixed factor or the independent variable is period and also type of investment. Next, we go to plots. In the plots, we are introduced to the horizontal axis and also the separate lines. So we select the period, then click Add, the type of investment, click Add, and the last thing we need to do is select period, go to horizontal axis, and the type of investment goes to separated lines. Then click Add. Press Continue. Next, we go to the EM means. In the EM means, we select everything. Take the Compare Main Effects, select Bonferroni, click Continue. Last thing we need to do in order for us to analyze the data, we click on Options. In the Options, there is Display. In the display, we select the descriptive statistic, the estimates of effect size, and the homogeneity test. Press Continue. Then, since we have successfully set up the data for it to analyze, then click OK. The SPSS software will automatically generate the analysis result. Alright, since we have the results generated by the SPSS, it is time for us to interpret the output. I have compiled 3 main points that will help us to understand the result. First is the descriptive statistic. This table is very useful because it provides the mean and standard deviation for each combination of the groups of the independent variables, what is sometimes referred to as each cell of the design. In addition, the table provides total rows, which allows mean and standard deviations for groups only split by one independent variable or none at all to be known. This might be more useful if you do not have a statistically significant interaction. The second that we want to see is plot profile. The plot profile gives data what it looks like and whether or not expecting to see a statistically significant interaction between two independent variables. Although this graph is probably not of sufficient quality to present in your reports, it does not tend to provide a good graphical illustration of your result. An interaction can usually be seen as a set of non-parallel lines. As we can see here, the data is not parallel lines. So, which means there is a statistically significant. The last but not the least, which is the main result, is test of between subjects effect. The particular rows we are interested in are the period, type of investment, and period and type of investment. These rows inform us whether our independent variables, the period and type of investment rows, are, and their interaction, the period combined with type of investment row, have a statistically significant effect on the dependent variable, investment interest. It is important to first look at the period and type of investment interaction, this one, as this will determine how you can interpret your results. You can see from the significant column that we have a statistically significant interaction at p equals to 0.818 level. You can see from the sig column that we have a statistically significant interaction at p equals to 0.00 level. You may also wish to report the results of period and type of investment, but again, these need to be interpreted in the context of interaction result. We can see from the table above that there was no statistically significant difference in mean interest and investment interest between equity and fixed interest, P equals 1.743, but there were statistically significant differences between period, P lower than 0.05. And in the report format, in the APA format, to reject the null hypothesis, we use this interaction effect as shown in this equation.